given the function f of x equals 4 plus x over quantity 2x plus 1, find the tangent line at x equals 1. Okay, so you hear a tangent line, first thing you think is slope. And so you're like, all right, we need to take the derivative, f prime of x. So you look at this and you're like, okay, well, my concern is here with this x, 2x plus 1. How do I do that? Not quite sure. And when you panic, your mind starts going off doing crazy things like, do I do substitution? Do I do separation of variables? Blah, blah, blah. Or partial derivative, whatever. Partial fractions. No, this is derivatives. Those are all integral type things. Derivatives they might not be easy, but they're at least usually straightforward. And so for this, it's just the quotient rule, or the way I do it is the product rule. So what we're going to do here then is we're just going to say, do the whole uv prime equals u prime plus uv prime plus u prime v. So, whoop, right down here, f of x, f prime of x, there we go, equals, and then the derivative of 4 is 0, because it's just a constant. And so then we have uv prime plus u prime v, where in this case u will equal x and v will equal 2x plus 1 to the negative 1 power. And I prefer to do the product rule with a negative 1 power as opposed to trying to do the quotient rule. It's just easier for me to remember. So for u, we have 1, and v prime, we have, all right, chain rule time. So we'll take the negative 1 down, multiply that by 2x plus 1 to the negative 2, then multiply by the interior for the chain rule, which will be 2. And I'll rewrite this again just so it's a little bit clearer. We have negative 2 over 2x plus 1. Okay. And so for f prime of x, I'll do it down here. And I'll change to red. So we have f prime of x equals u, which is x, times v prime, which is, we'll do a negative 2 over 2x plus 1, plus u prime, which is 1, over v, which is 2x plus 1. Okay? And we could try to simplify that by creating a common denominator and combining them. But for this, let's not worry about that yet. So we'll find the slope. So the slope would be f prime of 0, which is negative 2 times 0 over 1 squared, because 2 times 0, plus 1 over 2 times 0 plus 1. Okay, so this part goes to 0, that goes to 0, and we're left with 1. The derivative, or the slope, of the tangent line at x equals 0 is 1. Okay? So now that we have the slope of the line, we need to actually find a real point. So we have the point, or we have the coordinate, the x coordinate, 0. So I'll say y equals f of 0, or y coordinate, which is 4 plus 0 over 2 times 0 plus 1. And we don't have 0 as the sole term in the denominator here, which is good because if we try and divide by 0, the universe ends and we can't do that. So this point does exist. So we have 4. So we have the point, so m equals 1, and we have the point 0, 4. Okay, that's all we need. So I'll go to green. Maybe dark blue. Nope, I'll do green. So the equation for a line is y minus y1 equals m x minus x1, which would be y minus 4 equals 1 times x minus 0. We have y equals x plus 4 as our tangent line. Haha, it's even a possible answer, which is good. So, right there, y equals x plus 4. So the idea here of the tangent line is you need a point and you need a slope. The point is found by taking the coordinate you're given, plugging that into the equation, and the slope is found by taking the derivative and then plugging in your point, in this case, x equals 0. You take those, y equals y1 equals mx times x1, quantities. Solve it in terms of y. Now you have your tangent line. And that is